Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. What is the major product of this reaction? I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. So what is the major product of this reaction? This is actually succinimide. Okay, and here KOBr. What is the product? Now if you look at KOBr, you may consider it's the equivalent of KOH plus bromine. Now this way reaction of cold dilute KOH with halogen, these hypohalite salts are produced. Now if you look at this bromine, here the oxidation state is +1, so it is oxidizing agent 2. Not only that, if you look at this NH is significantly acidic. Now the acidity of any molecule is judged by the stability of conjugate base, means this N-. This N- is student doubly stabilized by resonance. So one resonance could be like this, another resonance could be like involvement of another carbonyl group. So this negative charge on this nitrogen is doubly stabilized by this oxygen as well as this oxygen, means this NH bond is significantly acidic, so deprotonation is easier. So under this reaction condition, this could be deprotonated and produce N-. Now in the next step, what you can expect, this N- can react with KOBr. Question why? By the way, KOBr will not be there, it will be converted to OHBr because it abstracted the proton, so it will be converted to OH. Now in the next step, this bromine oxidation state is +1. +1 means you can expect this is electron deficient bromine or it is electrophilic. Consequently, this nitrogen anion, which is nucleophilic in nature, will attack and this OH will leave. Now ultimately what will be the product? This will be NBr. But still this bromine is attached to electronegative atom nitrogen, so it is also not stable like the previous one where bromine was attached to oxygen. By the way, do not get confused why bromine is having +1 oxidation state, because bromine has a bond with oxygen. Oxygen is relatively higher electronegative with respect to bromine. That's why it has a +1 oxidation state. Now in the next step, what can happen? So what comes out here? Hydroxyl anion. So it can act as a nucleophile. So it will attack here, it will open up, come back, and it will produce N-. Look at very carefully, student. Sometime you need to write or you need to know the mechanism, it will help you. So I know it's a hard work, but please try to do it. Now in the next step, okay, OH is produced, but look at the medium. Medium is actually basic. So what it will do, this proton will be abstracted and it will result CO-, and obviously in order to neutralize the charge, potassium which is present in the medium as a counter cation, it will be there. Now if you look at this N-, negative charge of nitrogen, what it can do in the next phase, it can give this negative charge here, it can open up, then it can come back, and in the next step this bond pair will migrate on nitrogen. Why? Because this Br can leave. Now by the way, this bromine is actually leaving with its lone pair, so you can say it's a leaving of Br-. Anion is leaving. Previously bromine was in plus oxidation state, right now it's leaving as anion, so it is more stable because bromine is an electronegative atom. Now in this context, what does it produce? It produces this group, it's called IISO-NET. By the way, do not get confused with RNC. This is isocyanide, it is IISO-NET. Now since this carbon atom is attached to two electronegative atom, oxygen and nitrogen, so this carbon atom is electron deficient, or you can say it is electrophilic, delta positive. This oxygen is delta negative, nitrogen is delta negative, so it is electrophilic. Consequently what can happen? The hydroxyl anion present here, it can attack and it can open up. So it can open up, it will come back, and this bond will be opened up. So what it will result? It will result CO2 minus K plus. Now here it is N minus. Now double bond O, again OH. Now by the way, this OH is not stable, it's a carbonic acid amide. So first of all, this proton will be shifted from here to this nitrogen. Okay, now this is gone, so it is O-, and in the next step it will undergo decarboxylation. What do I mean? So it will push here, it will open up, come back, it will go. So what it will result? It will result in NH-, and obviously here CO2 minus K plus. By the way, remember NH- is a very strong base, amide. So How? What it will do? It will try to abstract a proton. From where it can go abstract proton? So it can abstract proton again from unreacted this NH bond. Not only that, it can abstract proton from OH also. So possible because it's a very strong acid. So it will abstract the proton and it will result this side NH2 and this side CO minus K plus. By the way, you may think one question that sir, N minus abstracted proton to form NH2. Why not carboxylate abstracting proton to get carboxylic acid? This is because carboxylic acid under this alkaline medium doesn't remain in acidic form, it forms the salt. But compared to this NH2, it's a very strong base and N minus is not that much stable like O minus. Why? Because carboxylic acid case, the negative charge has a resonance stabilization. Not only that, the negative charge localized on more electronegative atom oxygen, so more stable. But in this case, negative charge is on nitrogen and no special resonance is available, so it is not at all significantly stable. So in this way, these will be the product of this reaction. Now next, if you look at here, what is the major product of this reaction? Obviously, according to our discussion, is option A. Now if you get this question in your exam less than 30 seconds, how can you solve? First of all, if you look at this option, it is illogical. Why? Because CH3 is attached to nitrogen. Did I give any reducing agent? I have given oxidizing agent KOBr. So this carbon could not be reduced into this methyl. So it's an illogical option. Not only that, did I mention any workup? No. Here COH given. By the way, if you look at here, the without workup product is also available. So you need to focus here also. Okay. So this is gone option B, option A versus option C. Now if you look at option C, KOBr. Okay, so in this case, how can I get it? Actually, it's a Hoffmann degradation reaction which produces amine from acid amide through a removal of carbon dioxide, and that's why remember this reaction is called step down reaction. Now here I need this product, but did I have it? I have taken the succinimide, so not possible. So if I have taken this reagent, I could have been get this. So this is also gone. So what is remaining? Obviously option A. If you think like that, okay, CO2 will come out, and here how many carbon will remain? 1, 2, 3. Now here 1, 2, 3. So carbon count point of view also these matches. So option A will be the right answer. But remember one important statement, that Hoffmann bromamide degradation or Hoffmann degradation reaction produces primary amine from acid amide or imide. Now why imide? Because this succinimide case, there is a very unique thing. First of all, here if you take this carbonyl is electron deficient, and by nucleophilic attack on that carbonyl carbon resulted in N minus, means this anion generation, which is actually the intermediate. So that's the reason, because of specific reaction condition, these reacts and ultimately produce this option A as the major product. So this is the overall discussion. I request everyone to like, share and subscribe this video, and if you really enjoy the content, please help this channel to grow. And if you have any doubt regarding the logo of this channel, I request you please read this part. Remember, I never support any kind of brutality. So thanks for watching. See you in my next video. Bye bye.